Hello and welcome to the To Do Dot presentation. If you always forget to take out the trash or find focusing on homework impossible, we may have the solution you need. The goal of our project was to create a simple device that helps users start tasks and focus on their work. Our solution is the To Do Dot, a single button alarm that is set by a user's phone using Bluetooth. The To Do Dot has two modes, the first being a daily alarm. Once the alarm is set, the device disconnects from Bluetooth and can be placed near the task users want to complete. When the device alarms, users must go to the task location and manually press the button to turn it off. This helps users initiate their task and also helps instill habits by having tasks completed at the same time every day. The device also functions as a Pomodoro timer, enabling users to work in productive, timed periods. By having a tactile click and changing colors, users can better distinguish between when they should work or break. The phone application can be used separately in case users do not have the physical To Do Dot. However, having a separate device ensures that users aren't distracted by their phones, and it forces them to go to the task location.
For making the physical device for To Do Dot, we have decided to make a CAD modeling. Each of us drew our ideas in the early stage, and we have 5 C sketches which you can see on the left picture. We brainstormed further for a few more days, setting requirements, and made the final design mock-up by hand sketch. It includes the exact shape of the To Do that we want to design, and also the dimensions. Now you can see the CAD model of To Do Dots. There are 4 main sections of the physical device. The top section, which is essentially the lid, the top section, the middle section, and the bottom shell, which have been merged together to a single device that you can see in the middle. So here are the physical dimensions. The height is 10 centimeter, the diameter is also 10 centimeter, and the thickness of the shell itself is 2 centimeters. So listing the components, in the top section, there's gonna be the LED, the button, and the speaker, which will be resting on the top, protruding out. In the middle section, we'll be having our main hardware component, which includes the circuit, the Bluetooth button, the breadboard, and all sorts of wiring. In the bottom of the device, you can see a small space for the battery compartment where the actual battery is going to be resting, and underneath that the bottom lid it's gonna get attached, making the To Do Dot complete. In future, our primary goal would be to decrease the cost and size of our To Do Dot by primarily using individual wireless chips instead of breakout boards, and also adding a screw-on mechanism in each of the 4 compartments for ease of access.
We developed an app with a to-do list, Pomodoro calendar, and a connect page. This is our home screen where you can go to all the different pages. First, I'll show you how the Pomodoro page works. Here, you can select 25 minutes for studying or 5 minutes for break time. You can also play and pause the timer, and when the time is up, it will connect to the To Do Dot device to set off an alarm. From the sidebar, you can go to different pages as well. The to-do list opens to show a list of ongoing tasks. From here, you can add, edit, delete, or complete your to-do list. You can add tasks from the Add button, set a title, a description, select date and time, and save it. Once it's saved, it will show up in the to-do list. You can also edit tasks by sliding to the right, or you can also delete them by sliding to the left. Once you completed your task, it will show up in the completed task page. Here, you can do most of the same actions, and when you uncheck your completed task, it will move it back to your to-do list.
This is the calendar page. It shows you the events that you've added sorted into the days of their respective alarms. You can display the calendar in a number of different formats: 2 weeks, 1 week, and 1 month. The Add Task button works the same as on the to-do list. This task will now show up in the calendar and on the to-do list. There is also a sidebar where you can go to navigate between the different pages easier. Through the sidebar, we can access the Settings page. From the settings, the user can view their time zone information. Users can also reach the Connect page from the settings. The Connect page is where the user will be able to connect the device to the app over Bluetooth. From this page, you can enable or disable your phone's Bluetooth. You can also interface with your phone's Bluetooth settings and make the app discoverable over Bluetooth for a set period of 60 seconds. Once we're working on a published app, not an emulator, we'll be able to use the Select Connected Device page and the Explore Discovered Devices pages. The Select Connected Devices page will allow you to choose which connected To Do Dot you'd like to upload the information to. You will be able to refresh the list of connected devices from this page as well. The Explore Discovered Devices page will allow you to see nearby devices and connect or disconnect from them. We tested each of the pages by using all of the features and functionality on each page. There are additional tests for interfacing with Bluetooth that will be explained later. In the future, we'd like to implement push notifications on the phone. This would allow the app to work completely independently of the device. We'd also like to set up user authentications. This would allow a single user to track their tasks on multiple different devices. We'd like to allow for repeating alarms on tasks, and we'd like to add a track time spent on task mode. This mode will allow the user to track how long they spent on each task using the external device.
Since Android Emulator does not directly work with Bluetooth, we will showcase the modes using a computer Bluetooth console, sending commands like the phone app. Here's a photo of the device. As you can see, there's a speaker, button, and light all connected to the Bluetooth ESP chip. The module is powered by 4.5 volts from 3 AAA batteries. The device has two modes, Pomodoro clock mode and alarm mode. For Pomodoro clock, there are two time periods, work and break. The work time will be 25 minutes and the break time is 5 minutes. But for this demonstration, they're 10 seconds and 5 seconds. Now, if the user holds the button down for 3 seconds, the device is theoretically placed into deep sleep mode until the button is pressed again. The functions will cease and the battery usage will be very minimal. If the user holds the button down for 6 seconds, the device will restart. It'll look to reconnect with the app and can be reset. For alarm mode, the device receives a time to go off. Once the time is reached, the device buzzes and the light turns red until the user clicks the button. The alarm then resets every 24 hours.
To test the speaker, we used a noise level app from 5 meters away. The resultant sound intensity was roughly 50 decibels. The device connects to a computer in roughly 7 seconds with an unobstructed distance of more than 5 meters and appears to read and write from the computer immediately. It can display a full range of RGB colors and currently costs under $29 to make. Going forward, we would like to download the app onto an Android device, allowing us to test directly with the button. We would also like to lower the power usage with Arduino deep sleep modes and enable multiple alarms. The cost can be lowered significantly if components are shipped in bulk from cheaper distributors. For example, the cost of our ESP32 board from Amazon was $16 compared to $5 or cheaper on AliExpress. To decrease the size, the batteries should be replaced by a 5-volt coin cell battery, and the components should be connected on a single PCB board. A simple ESP32 chip should also be used instead of a hobbyist development board.
In summary, we have made a printable CAD design for the device casing, created an app with pages and functionality for the various modes, and made a device that can utilize the various modes after connecting over Bluetooth. So that's about it. Thank you for listening to our presentation. I hope you are as excited about this project as we are. Till then, stay safe and have a nice day. Goodbye.